Hello, and welcome back to my channel. I'm Snacks, the Druid, and in this video, I am showing how my distribution of primes thing that I found and the cross primes thing that I found interact and where it kind of collides together. And so we've got 0 right here, right? Because 0 is part of the stack sequence that I made a video on. But it's also, where natural numbers kind of start is at 0. And so we have the standard, 0 to 10 so that we're branched in 11. And the reason that I do that is because now we're incrementally counting this way, but in a weird way, we're still incrementally counting up this way because the numbers are kind of repeated is where I've kind of landed on that. And underneath, I've got my distribution of prime numbers thing. And so just so that people are on board or understanding, this whole table and this whole process is not the distribution of prime numbers. The distribution of prime numbers are the exclusive primes generated by each horizontal. And so now you have the distribution being 2 and 5, 3 and 7, 0, 5 and 11, 13, 7, 17, 19, 0, 11, 23, 0, 13, 29, 31, 0. And here are some questions that I would like to ask about it. Why does 5 never show up alone? Why does 11 never show up alone? You know that if a prime has double plus 1, it's going to come in a pair. So 23 is never going to show up alone. Why do only certain primes show up in pairs, and why do certain primes only show up alone? Is kind of a weird question to ask, I guess. But let me point you in the direction of where I'm going. So there is this specific diagonal right here, and it stems from negative 54, applying that sequence. And it goes up. It goes negative 42, negative 30, negative 18, negative 6, 6, 18, 30, 42, and then it collides with 9 on the natural numbers, the real numbers, not this kind of like imaginary space, but the real numbers. It collides with 9, and then the next on the diagonal is 21, which is exactly half that of 42. So we've got this kind of thing right here going through the diagonal, but more importantly, 6, 8, 30, and 42 are right here. You have 6, 18, 30, and 42. And 18, 30, and 42 are the first 3 cross primes. And it's kind of weird to me that this shows up and is repeated right here after it kind of like breaches that 9. And so what I think is actually happening is from here, it's like this one diagonal, and then you hit another diagonal right through here, negative 27 going all the way up through it. And then it hits another diagonal right through here, because at the 7 branch right here, you hit 4, and 7 is the 4th prime number. And along this diagonal, you get 4 squared, you get 7 times 4, you get 4 times 10, 13 times 4, 4 times 16, so 4 cubed, and then 76, I believe, is 29 times, and it's 19 times 4 is 76. So you get this prime pattern almost of like just multiplying by 4 outside of like 16, 64, and 40. Because 7's a prime, 13's a prime, 19's a prime, and that's kind of something. And it kind of has this entire branch almost. And then to me, another diagonal forms kind of like right through here in this kind of like primey category, but there's 49 right there, which kind of like blocks it, I think. But the reason I think that this is interesting with 7 specifically, because 7 is a number. It certainly is. But the reciprocal of 1 over 49 is 0.020408 16 32 and so on and so forth. And it's really weird that it makes that repeated pattern, right? There's also a weird curiosity going right here where all these multiples of 5 summing from 55 going down, and 55 is of course on the Fibonacci sequence. 55, it goes through 5 and then gets replicated right here at 25 because that's 5 squared, and then 30, 35, 40, 45, and you'll eventually hit 50, 55, 60, 65, and so on and so forth because it goes on infinitely. And so I just kind of wanted to draw people to the fact that this weird thing is repeated perfectly right here in these cross primes. And one of the weird reasons I think this happens is how like geometry hits numbers or how graphing hits numbers. And so take a circle, 0, the whole in mathematics. And this is what the basis of mathematics to me is all about, is that you put a line through the center, and now you have one half and you have the other half. This side is not that side and that side is not that side. And so you have 1 on either side, but those 1s are different. And in that we have 2, and that's why 2 is the first prime number. And so when you take this into account, now you have the grid lines, because you can fit a grid in there. You have plus plus, plus minus, minus plus, and minus minus. But let's say you draw a 9 up here in the plus plus. Now you get this, you get this, and then you get this. And that kind of dynamic is perfectly reflected in this, I think. I don't think that's normal. I don't think anyone has ever looked at numbers like this and drew that kind of thing. And it's, you know, it's perfectly diagonal. Everyone likes to talk about diagonals, and, you know, maybe this hits right through here. Maybe that's another diagonal. I really don't know. I don't know. This one I think is solid, that's solid, that's solid, and that's solid because of the way 12 kind of functions. Right through here in this space is kind of like a gray area for me where, you know, maybe this is all a thing because this right here is kind of a triangle. It's chaotic. I'm chaotic. But yeah, it's just kind of like a weird diagonal thing right here between 9 and 6, right? And with the snack sequence, in conjunction with the Fibonacci sequence, because I still think it's a pretty mind-blowing thing that I found, because you go like that, and then next on the Fibonacci sequence is that, then next is that, then next is that, and then the snack sequence happens and it bounces back in on itself. And so you go right to there, you go right to there, you go right to there, and then you go right to there before you return. And so that is another thing that gets reflected right there and gets reflected right there. And I know I sound like something, I don't know, but it's just how I see numbers. So remember, this is the distribution of prime numbers, and it goes infinitely. It never breaks, because this never breaks, because people have pointed out to me in the comments that primes can only form in these. Well, if that's the case, why has nobody ever written about this? Why is this just a new thing for me? Why am I having to find this and note it and make weird videos on my YouTube channel that people have show interest in? Which I do appreciate all the comments so far, because constructive criticism and asking questions is the only way to dig deeper at the truth. Now, the big thing is, what is the application for what I've been doing in all of my work? And I'll write it here real quick. But my application for what I think this is important for is metaphysics. I know, it kind of got ousted once people started doing research into quantum physics, but at a certain point, there's a significant overlap into the study of metaphysics and the study of quantum physics. Just quantum has to do with like atoms and protons, electrons, and all the tiny, teeny, bitsy, itty-bitty things that physics is capable of. But Aristotle, who is a based Chad bro, Aristotle said that there is no physics without first metaphysics. So, hey, maybe if we take a little bit of a sidestep back and start looking at metaphysics stuff, maybe it'll lead to better understanding of the quantum universe. Ever think about that? You ever think about, this is a wild one, you ever think about barycenters? Barycenters? The center of gravity between, or the center of mass between two objects. You ever think about how the sun and Jupiter, J. Diddy right there, are so massive that they both orbit around this infinitesimally small point right here that is approximately 1.07 solar radii from the center of the sun? You ever think about that that's just something that exists in our universe? How wild! How wild! To me, that says that this little infinitesimally small point that has no mass probably generates gravity at some point, and this goes for every barycenter for the most part. I mean, what is it that pulls things towards, with mass? I think it's the center of mass. I think it's these barycenters, and a couple people I think would agree with my sentiment on that one is Gottfried Leibniz, the father of calculus, for people who don't idolize Isaac Newton, and the creator of binary. But the thing of his studies that really reached me was his study on the monad, the start of a sequence in Greek mathematics. But the monad to him were these infinitesimally small points that God, or whatever construct that humans have come up with to explain the greater expanse of the unknown. That thing just put all these little teeny infinitesimally indivisibly small points all the way across the universe, and that's what holds everything together. The other person that I think would be on board for my thought process with barycenters being the gravity generators, I don't know, would be Rene Descartes, following his interest into what he called vortex theory. If you don't know what vortex theory is, basically Rene Descartes in the 1500s, I think, was Rene Descartes. Yeah, I think it's 1500s. It was either 1500s or 1600s. He is the one who came up with this idea that in the inky black watery expanse of space, there were these tiny little infinitesimally small vortexes that were just constantly spinning around the sun, and that's what created the heliocentric universe that we experience, or whatever. I think he was a heliocentrist. I think that was the common form of belief at that point, after Copernicus was then. But then there was also Tycho Brahe, who had his own model. If you want to get into the Tycho model, that's a fun one, because this Earth is the center of the universe, and the moon and the sun orbit around the Earth. But every other planet in our solar system orbited around the sun. I don't know. He had that idea, but it didn't stop his mathematics from being precise enough to get his nose chopped off. But yeah, this vortex theory, just little infinitesimally small things in the great expanse of space, close to the sun, close to wherever, just swirling, and in the nothingness that is space, it caused enough motion to keep everything in check. All the checks and balances were there because of these infinitesimally small points. And when I think about a barycenter between Jupiter and the sun, both of those objects are spinning at a very specific rate. I think that spin would be conserved in that little teeny infinitesimally small point. I'm sure I'll get physics people who disagree with me. I don't care. Be a hater or be, interested and open-minded. I don't know. But the reason I bring this one up is because if you look at, Pluto and Chiron, that point is kind of replicated between the two of them. I want to say proportionally between the two of them that it is to Sun and Jupiter, which is interesting that it shows up twice in our solar system, I think. But anyhow, I'm detracting. My big thing in my research that I've done is on metaphysics, and the person that I've really latched onto his studies is Gottfried Leibniz. And so I've done a pretty extensive amount of research and study into number bases, and I'll get into that because I think number bases are an interesting mathematical thing. And I think I have some really interesting insights and ideas that might expand your ideas of number bases. So in a nutshell, in summation for this video, this is the distribution of primes table expression. This is the cross primes, how you find them. And this is how they connect and overlap, because this going into 9 is the exact same as this, which is, again, just this flipped over the X and Y axis. Comes right back through there. I just think that's weird. I think that's something to know, and maybe it means something, maybe it doesn't. Who knows? Who cares? But thank you for watching. If you like my videos, please like them, comment some critiques. Just don't be rude. Everyone has been, good so far, which is nice. If you would like to join my Discord, my link is in my channel bio. And again, I just want to thank you for watching. Please subscribe if you want to keep learning about this kind of weird stuff that I like to do. Okay, have a good night.